Everybody, let's talk about activity 7.2, choosing doors. So imagine that you're on a game show and a contestant is presented with three doors. One door hides a prize and the other two doors have nothing behind them. In the applet that we're going to look at, there's a goat. Okay, obviously nobody wants a goat, so that would be a loss. So what you do is a contestant chooses one of the doors by number. The host, knowing where the prize is, reveals one of the empty doors that the contestant did not choose. So for example, let's say the car is behind door number 1, but the contestant chooses door number 2. Well, obviously, the host knows where the car is, so he's going to present the person door number 3. Says, okay, I know you chose 2, but here's door number 3, and it's always going to be a goat. That guy is always going to show you the goat. So now it's up to you to make a decision. The host then offers the contestant a chance to stay with their original door or switch to the remaining door. So now that you have chosen door 2, he shows you that the losing door is door 3. Do you want to stick with your gut and stick with 2, or do you want to switch to 1? The final door is chosen and is open to reveal that the contestant has won the prize. So what this is called the Monty Hall problem. And Monty Hall was a famous host who used to host the show Let's Make a Deal. So this is a statistics question based off of this entire scenario. So now originally in class, I was going to give everybody a chance to play it, but we're not in class together. So what I'm going to have you do is I'm going to have you do this on your own. So if you take a look at the screen, you're going to go to this applet, and this is linked in Google Classroom here. And what I'm going to have you do is I'm going to have you play this game 100 times. And it's going to go very quickly. You don't have to sit here and click 100 times. So what I want you to do is I want you to go down here. First of all, make sure you turn off animate. If you have animate on, it's going to take forever. So what I want you to do is I want you to play this 50 times where you stay. So go to here and click stay 50 times and hit go. So you can see what the results are if you stay 50 times with your original choice. Now what I want you to do is I want you to change it to switch, do it 50 more times, and you can see that you now have 100 results. So you played it 50 times where you stayed, 50 times where you switched. And we're going to take this and we're going to go back to our notes and fill this in. So take a look at your numbers that you have there. So it was 14, 36, 36, 14, and that's just purely a coincidence. It will not be flipped like that all the time. So I go back to my notes, and now I'm ready to fill in my two-way table. So if I remember correctly, when I stayed, I won 14 times and I lost 36 for a total of 50. And then that switched on me. When I switched, I won 36 times, lost 14 for a total of 50. I add a cross. That was 50. That was 50. And that's 100. That will not be like that. I don't think it'll be like that all the time where it ends up being 50, 50, 50, 50. Okay, so now we're ready to answer the questions. Based on your table, if the contestant decides they will choose to stay with their original choice, what's the probability that they will win? Well, we're looking at this column right here. If they stayed, so we know that's out of 50 because we stayed 50 total times. How many times did they win? Well, that's 14 out of 50, and that's 28%. So 28% of the time you win if you stayed. But what happens if you switched? Well, now we're over here. Again, we switched 50 times, so we know it's out of 50, but this time we won 36. So that's 36 out of 50. And that one totals up to 72% of the time that you won. Well, the question is, are these two probabilities the same? Well, clearly they're not the same. We're comparing 28% to 72%. That's not even close. So does staying or switching affect your ability to win? Is your ability to win dependent upon whether you stay or switch? Well, if those two probabilities were the same, the answer would be no. It doesn't matter if we stay or switch. You're going to win the same percentage of the time. But not only were the percentages different, they are really, really different. I mean, heck, that is a huge difference there between those two. That's what, 44%? So there's such a difference that we can say, no, these are not the same. And your ability to win clearly depends on whether you stay or switch. Now, there is an actual explanation behind this that I don't have time to go through. Maybe when I go back, I will go through it with you. But switching is your best option. It actually doubles the number of chances that you have to win. But I can explain that at a different time.